Okay, let's look at this analysis again. So in this analysis, what we did was instead of giving a cosine function, we give a complex exponential signal and we solve the differential equation and we got to this stage. And when we get to this stage, if you look at it a little bit more closely, you say, okay, what have we done here? What we have done is we've taken out the omega t terms from the equation, right? So we took out this e to the power j omega t, e to the power j omega t, e to the power j omega t, which was common for the entire circuit. And we've already said that in a linear circuit, the frequency is not going to change. So is there some way where we can actually start our circuit analysis from this step instead of going through all these steps and coming here? That would make our work easier, right? And one of the ways you can do that, and you can see that you can do that, is by noticing that when we write this voltage Vm here, you're actually writing e to the power j0, right? Because the phase for the input was 0. So if you write your input only in terms of the amplitude and the phase, which are the only important characteristics, the changing characteristic in your circuit, and then you write your current as the amplitude and the phase alone, can you make your circuit more easier, solving your circuit more easier? The answer is yes. And before we see how we sort this circuit out in that way, this form of writing the input without the frequency, so this is called the phasor representation of the signal. Okay, so this is the phasor representation of the signal. You could also write this in the polar form, right? Instead of the exponential form, this is basically a complex number, or you could write the current in the phasor form like this. And this is equivalent to writing the current as Im as the amplitude and the phase phi here. And you know that this is a complex number and you know how to convert it into a complex number. E to the power j phi becomes cos phi plus j sine phi, right? And this is another way of representing the phasors. Okay, so we're going to use this concept of phasors to develop a method of solving AC circuits, which is more simplified than the methods we have seen before.